Today's topic is transponder and its types. So, in the previous session, in the previous videos, I have said what is a microwave link, what is a satellite, and what are the classifications of satellite, what are the advantages of satellite, and under that, we are having the type of satellites. So, we have seen with the communication satellite in the previous video, and I have explained each block under the communication satellite and what are the applications of communication satellite. Okay, so in the previous session I have said that a satellite is a microwave link repeater that will be revolving around the earth. It is receiving the signals from the transmitting earth station, and it is going to be amplified these signals, and it is going to be down converted and send these signals to the receiving antenna. So, nothing but a satellite is a physical object that revolves around the large body. Okay, that is an satellites. And I have said that number of advantages and disadvantages of satellites. And when we are calling as a satellite is a microwave link. So, what is a microwave link means? It is having the same work as a copper wire or a fiber optic cable or a coaxial cable, but in a different manner. That means it is used for point to point communication between the repeaters. That is in the transmission of the repeaters, it is going to be doing same work. Okay, for the transmission of signals it is using. And when we are having the satellite classifications, we are having number of satellites based on the purpose, based on the height, based on the usage, or based on the working area. Okay, so like this we are having number of types of satellites. So initially when we are having the satellites, we are also having the uplink frequency and downlink frequency. So when we are having in the satellites, we are using the transponders. So in order to have the frequency translation, we are going to be using the transponder in the satellites. So what is a transponder means? It is a transmitter receiver combination in a satellite. So we are going to be calling as transponder. So the combination of transmitter and receiver, that means it will works as an transmitter and receiver. Okay, the combination in our satellite is going to be calling as transponder. Okay, that means which will be acting as an RF repeater stations. Okay, and in our typically the communication satellites will have 12 or 24 or more than transponders can be used. Not only a single transponder is used. So what is the main function of the transponders when we are using in the satellite? So that means it is mainly receiving the uplink frequency from the transmitting earth stations, and it is going to be amplified the received signal, and that signals are going to be translate them into the downlink frequency. Why? Because in our satellite the uplink frequency is 6 gigahertz and the downlink frequency is 4 gigahertz. How can be done means by the help of transponder it can be done. And whenever it is going to be translated to downlink frequency, that is going to be amplified again, and downlink signals are transmitted to the receiving earth station. So that is the main function of transponder. So when we are having the transponders in our satellite, in that we are having the three types of transponders. So the first one is, so in this session I am going to have a types of transponders. Okay, so what are the types of transponders, and I am going to explain the each type of the transponder, and number of applications under this we are going to be seeing with this. Okay, so the types of transponders means we are having three types of transponders. That means basically the usage of the configuration. That means whenever we are classification is going to be done, it is nothing but an parameter is going to be involved. So based on the configuration parameter, that is going to be classified into three types. That is single conversion transponder, double conversion transponder, and the third one is regenerative transponder. Okay, these are the types of transponders. That is single conversion transponder, double conversion transponder, and third one is regenerative transponders. So how it will works? So whenever we are having the single conversion transponder, the term, that is a single conversion, okay, the term which will indicating that only a single frequency translation process is going to be done from the received signal to the transmitted signal, which is taking place within the satellite. That means only a single frequency translation is going to be done whenever it is going to be receiving the signals from the receiving antenna. Okay, so that means in the satellite it is going to be doing the single frequency translation process from the received signal to the transmitted signal takes place within the satellite. So in this, the first one is we are having the receiving antenna, the uplink frequency, that is 6 gigahertz in our C band. Okay, so that is going to pick it up by the receiving antenna, and that is going to be given for the LNA, that is low noise amplifier. That means the uplink signal from the receiving antenna is amplified by low NA. LNA, okay, that is low noise amplifier. That means from the receiving antenna which is going to be taken signals by the receiving antenna, that is given for the LNA, that is low noise amplifier. That is going to be doing what it does means it is amplifying the signals which is given by the receiving antenna. And in this, what is there means it is nothing but an gallium arsenide fed circuit to amplify this signals. Okay, so the next it is going to be given for the mixture. So what is the use of mixture means it is nothing but a combination of signals. Okay, so whenever we are having this from the local oscillator, it is also giving some signal, that is it is a stable frequency of signals that is going to be given to mixture circuit. Okay, and this mixture is going to be used to translate the uplink frequency, that is 6 gigahertz, into the downlink frequency as 4 gigahertz. That means I have said that in any communication systems the mixture can be used for two combinations. That means it which can be used for subtraction of the signals, or which can be used for the addition of the signals. So whenever it is used in this, it is doing the subtraction of the signals. That means it is going to be used to translate the uplink signal frequency into our downlink frequency, that is 4 gigahertz. And the next one is amplifier and BPF, that is BPF is the button band pass filter. Okay, the mixture circuit or the mixture output is going to be then amplified again. Why? Because I have said that whenever it is going to be downlink frequency, that it should be amplified first. Okay, so in this also, whenever you are using the amplifier which is going to be having the amplification of downlink frequency, and it is going to be fed to band pass filter. The what is the purpose of band pass filter means it is only allowing the 4 gigahertz frequency range of signals. Okay, and it is going to be used to channelize the output. That means in order to use that process, okay, it is going to be used, and it is going to be eliminating the harmonics which is present in our output. Okay, that is the purpose of BPF, band pass filter. Okay, that means the amplifier which is doing the amplification, and in order to increase the gain of the signal, and it is going to be fed to the band pass filter. What is the purpose of band pass filter means it just allows only the 4 gigahertz frequency of signals, and other than that it is going to be rejected, and it is also used to eliminate the harmonics. So like this it is going to be using amplifier and BPF. Okay, and the next one is high power amplifier, that is shortcut is HPA, high power amplifier. So this downlink signal which is going to be amplified, that can be having another amplification. Why? Because whenever we are having the signal to be transmitted to the earth stations, the gain should be in the power ranger is going to be very high. Okay, that means it should be having the power ranges, it should be very high. So in order to maintain the high power ranges, we are going to be using the high power amplifier. That means which will be increasing the power levels of the downlink signal frequencies. Okay, so that means that signals are going to be amplified by using the high power amplifier, just by increasing the power levels of our signals. Okay, so in this we are going to be using TWT, that is traveling wave tube. Okay, so that is going to be used. And the next one is BPF, that is the HPA output, that is high power amplifier output is going to be given, is going to be used for filtered, that should be filtered by using the band pass filter. So why? Because the last block which is to be sent to the transmitting antenna, for that we require filtration once more. So why that we are going to be using the BPF once. Okay, and it is going to be used to a filtered and is going to be passing the only 4 gigahertz of signals. Other than that, it is going to be eliminated. Okay, so that is the use of BPF. And the last one is transmitting antenna. So downlink signal frequencies or downlink signals are going to be retransmitted towards the receiving earth station. Okay, like this the operation can be done within the single conversion transponder. Okay, so whenever we are having the local oscillator which is going to be generating the 2 gigahertz of frequency, and whenever it comes under to the mixture, the inputs of the LNA, that is low noise amplifier, which is going to be giving 6 gigahertz, and the local oscillator is going to be giving 2 gigahertz, and in this mixture the difference of two signals is going to be 4 gigahertz. Okay, like that it is going to be getting the output as 4 gigahertz. This is the single conversion transponder. Okay, so this is about the single conversion transponder. That means the term single conversion refer to the that is going to be only a single frequency translation process from the received signal to the transmitted signal takes place within the satellite. And the first one is receiving antenna, that is going to be the uplink signal, that is 6 gigahertz in C band, that is going to be picked up by our receiving antenna. And the low noise amplifier, the uplink signal from the receiving antenna is amplified by the LNA, that is low noise amplifier. So it is usually we are going to be using gallium arsenide FET circuit. Okay, that is a low noise amplifier. And the next one is mixture and local oscillator. So these are used to translate the uplink signal frequency to the downlink frequency. So I have said that in the local oscillator it is going to be generating a stable frequency of signal, that is 2 gigahertz, and when we are getting some low noise amplifier it is 6 gigahertz, and in the mixture it is going to be doing the difference of two signals, and we are going to be getting the 4 gigahertz of signals. Okay, so like that it is going to be generating the 4 gigahertz, that is downlink signals is going to be generated by the use of mixture. Okay, and the next one is amplifier and BPF, that is the mixture output is going to be then amplified again, and it is going to be fed to the band pass filter. And what is the purpose of BPF is to allow the only 6 gigahertz frequency range of signals, and it is going to be used to channelize the output, and it is used to eliminate the harmonics. Okay, so that is the amplifier and BPF. And the next one is high power amplifier, that means the downlink frequency, that is 4 gigahertz, can be amplified by using the high power amplifier. So I have said that in order to increase the power levels we are going to be using the high power amplifier. That means generally in order to increase the gain also we are going to be using the high power amplifier, that is shortcutly we are going to be calling as HPA. And in this what is going to be used means it is nothing but an TWT, traveling wave tube. I have said that whenever we are using the applications at microwave frequency ranges, normal amplifiers cannot be used. So for that we are we have we are introducing number of devices. So instead of normal amplifiers, in that we are going to be having an amplifier calling as TWT, that is traveling wave tube, okay, which are going to be used at microwave frequency ranges. Okay, and the next one is BPF, that is band pass filter. The HPA output is going to be further filtered by using the BPF to it is going to be used to eliminate the harmonics. And the next one is transmitting antenna. So what it does means the downlink signal, that is 4 gigahertz, it is going to be retransmitted towards the receiving station. Okay, so this is about our single conversion transponder. And the next one is double conversion transponder. So the name already indicates that which we will be doing 2 times. Okay, so that means it is similar to the single conversion transponder only, but what is the difference means it is having the double frequency conversion is going to be done within the satellite. So what is the main advantage of double conversion transponder means it is used for flexibility, greater flexibility in filtering and amplification can be done very well. Why? Because I have said that whenever we are using the communication systems or communication blocks which are earlier you have studied, in that a single amplifier is not going to be used. Why? Because in order to have a better quality of the picture or quality of the signals, we are having a number of amplifier sections to have that. Okay, so the single amplifier is not going to be enough. So for that reasons, in this also we are having an amplification part. So in order to have a greater amplification, we can have a very quality of the signals. Okay, and we are having the greater flexibility in our filtering process, and the amplification can be achieved. So amplification and selectivity at lower IF level is going to be very easier. Okay, so the next is block diagram of double conversion transponder. So what is this means? In this, the uplink signal is going to be picked up by the antenna, and it is going to be amplified by the LNA, that is low noise amplifier, and it is going to be fed to the first mixture circuit. That means we are going to be getting the downlink signals, okay, and that is going to be given to the IF amplifier. Why? Because the mixture output is going to be in the ranges of RF signals, that is RF signals, and is going to be getting as IF means for the processing of signals we are going to be giving for the IF amplifier. So what is nothing but an we are going to be having an amplification of signals which are given from the mixture circuit, and that is going to be given for the another mixture circuit. Okay, so what it does means which will be transmitting the IF signal, that is 70 megahertz, into the RF signals, that is 4 gigahertz is going to be converted, and then it is going to be converted to, and then it is going to be applied to BPF, that is band pass filter, for eliminating the harmonics, and it is allowing the only the downlink signal, that is 4 gigahertz. And what is the use of HPA means, which is used for high power amplification. That means in order to increase the power level of the signals, that is downlink signals, that is going to be used, and this will be increasing the signal level, and this is going to be given for the BPF, that is band pass filter, for eliminating some more harmonics which are present in our downlink signals. Okay, then it is going to be given for the transmitting antenna. This will send the signal on its way over the downlinks. Okay, so there is a slight change between the single conversion and double conversion transponder. So why? Because you have to observe the figure that whenever we are using the single conversion method, we are having only the one mixture circuit, that is one with the combination of local circuit is going to be having a 1. Okay, so in this we don't have a single block, we are having the 2 times it is going to be used. So that is why it is going to be calling as double conversion transponder. So in order to have a quality, we are going to be using this. In order to have a selectivity, or in order to have a more flexibility, we are going to be using this. So in the down conversion transponder, the uplink signals is going to be picked up by the antenna and it is going to be amplified by LNA, and it is going to be fed to the first mixture circuit, and the mixture is going to be translates the RF signal, that is 6 gigahertz, into the IF signals, that is 70 megahertz, and the IF signal from the first mixture is going to be fed to the IF amplifier, so where very high gain is going to be achieved. So the output of the IF amplifier fed to the another mixture which will translate the IF signal into the RF signal, that is 70 megahertz of signals into the 4 gigahertz of signals, and then it is going to be applied to the BPF, that is band pass filter, for eliminating the harmonics, and it is going to be allowing only with the 4 gigahertz frequency signals. And next, the HPA, that is high power gain or high power amplifier, which will increasing the signal level, and it is going to be fed to the BPF again, and it is going to be providing the elimination of harmonics which are present at last most of the block. Okay, so once again it is going to be eliminating the harmonics, where it is going to be amplified to another signal, that is 4 gigahertz. Okay, so that is the use of this HPA and BPF. Okay, finally, which will be transmitting it is sending the signals on its way over the downlink frequency of signals towards the transmitting antenna. So like this, it can be having the double conversion transponder. And whenever we are using the double conversion transponder, from the local oscillator which will be generating a stable frequency that is 5930 megahertz of frequency, and from the LNA, that is first low noise amplifier, from that we are going to be getting 6000 megahertz, and it is going to be having injected to the mixture circuit, and from the mixture we are going to be getting that 6000 megahertz minus 5930 megahertz, that is equals to 70 megahertz of the signal. Okay, like that we are having the double conversion of this signals, that is we are using the 2 mixture circuit in this 2 times it is going to be converted, so that's why it is going to be calling as double conversion transponder. Okay, and the next one is regenerative transponder. So what does this means? Whenever we are using the double conversion or single conversion, it is not having any differentiation between the transmitter and receiver ends. So in regenerative transponder, which will be providing them where the receiver ends and where the transmitter begins, so it can having some differentiation of the transmitter and receiver sections, so that's why it is a regenerative transponder. Okay, so this is the figure of regenerative transponder, and what it does means, you have to observe the figure that in the previous figure we are having same as that, this up to this it is going to be clear, and it is having this section extra instead of some another mixture circuit. Okay, instead of band pass filters, instead of IF amplifiers, we are using directly, we are going to be using demodulator and modulator circuit. This is the extra circuit which is going to be used in this regenerative transponder. This is not going to be observed in our single conversion or double conversion transponder. Okay, so what is an advantage of regenerative transponder means, the receiver ends it demodulated output, the receiver will ends at demodulated output, and the transmitter will begins at the modulator input. So the uplink signal is going to be amplified and is converted, that is transmitted to a particular frequency, and then it is going to be demodulated for providing the baseband signal, that is voice, TV signals or any digital data. That means directly it is going to be demodulation is going to be done across the receiver end. Okay, the baseband signal is going to be fed to the modulator along with the carrier at downlink frequency. The signal is going to be then amplified, filtered and retransmitted over the downlink frequency. Okay, this can be done. And what are the applications of transponders? That means whenever we are using that satellite, almost that are going to be same for this transponders. Why? Because whenever we are using the satellite, in that only we are going to be using the transponder. So for this is going to be same applications for our transponder also. So what are that applications is, whenever we are using for the communication, they are used for communication purpose, and it is also used for navigation purpose, and it is also used for mapping, and it is used for astronomical observations. To observe the planetary part, we are going to be using this, and it is also used for scientific experimentation. Okay, when we are having some researchers, they are going to be using this. Okay, and it is also used for monitoring of the Earth's environment, how it is there. It is going to be observed by the use of satellite placing on the above the Earth curvature, and it is going to be getting some information from that. Okay, so that is the main applications of transponders. Let us have a quiz based on this. So what is the number of satellites present in the iridium system? So what is the number of satellites present in the iridium system? So how many satellites are going to be present in our iridium system? So first option is 72, and the second option is 51, and the third option is 66, and the fourth option is 32. So what is an answer? Please note this question. So what is the number of satellites present in the iridium system? The first option is 72, and the second option is 51, and the third option is 66, and the last option is 32. What is an answer? That is 66. So 66 number of satellites are present in the iridium system, not with the 72 or not with the 51 or not with the 32. That is 66 number of satellites are present in the iridium system. And the next question. So which frequency band is used for connecting the satellite system with the public switched telephone network? Which frequency band is used for connecting the satellite system with the public switched telephone network. So what frequency band is going to be used for connecting the satellite system with the public switched telephone network? The first option is L band, the second option is Ku band, and the third option is C band, and the fourth option is Ka band. That means what frequency band is going to be used for connecting the satellite system with the public switched telephone network. Okay, so whether it is L or Ku or C or Ka. So what is an answer? Please note this question. So which frequency band is used for connecting the satellite system with the public switched telephone network? The options are L band, Ku band, C band, and Ka band. Okay, so what is the frequency band which is going to be used for connecting satellite system with the public switched telephone network? That is PSTN. Shortcutly we can calling as PSTN. So what band is going to be used? Let us have an answer. That is Ka band. Okay, so in the previous sessions I have said that whenever we are using the satellite communications or satellite systems, most probably we are going to be using with them C, Ku and Ka band. Okay, most probably. So that is the reason you can guess with this answer. Why? Because L is not going to be used, Ku can be having some probabilities, and C is also having some probabilities, and Ka band is the correct answer. Okay, so Ka band is the frequency band which is going to be used for connecting the satellite systems with the public switched telephone networks. Okay, this is an answer. Next question. What provides the sufficient drive to the final power amplifier? What provides the sufficient drive to the final power amplifier? So the first one is intermediate power amplifier, and the second one is operational amplifier, and the third one is power driver circuit, and the fourth one is up converter. So what will provide the sufficient drive to the final power amplifier? The first option is intermediate power amplifier, and the second option is operational amplifier, and the third one is power driver circuit, and last one is up converter. So what type of is going to be providing the final power amplifier? So let us note this question. So what provides the sufficient drive to the final power amplifier? The first option is, that is A option is intermediate power amplifier, and the B option is operational amplifier, and the C option is power driver circuit, and the D option is up converter. So what is an correct answer? That is whenever we are having the final power amplifier, so what it will providing the sufficient drive to the final power amplifier? So whether it is intermediate power amplifier or operational amplifier or power driver circuit or up converter. Okay, so what is an sufficient drive to the final power amplifier? So let us have an answer. That is A, that is intermediate power amplifier. Why? Because you can see in the previous sessions that whenever we are having the power amplifier, the last stage for the above to the beyond the receiving antenna or transmitting antenna, the last stage is going to power amplifier, and before that we are going to be using the intermediate frequency power amplifiers. Okay, that means the input is going to be intermediate frequency. So for that we are going to be increasing the power levels, and that is going to be given for the transmitting antenna. So that is an correct answer, that is intermediate power amplifier. Okay, the next question. Which one of the following does not fall under the position system? Which of the following does not fall under the positioning system? The first option is radio system, and the second option is celestial systems, and the third option is AHRS. It is nothing but an resource systems. Okay, and the last one is mapping navigation system. Which of the following does not fall under the positioning system? So what is an option? That means it is not under the positioning system. It will not detect that signals. Okay, so what is that system which will not fall under the positioning system? So what is an answer? Please note this question. So, which one of the following does not fall under the positioning system? The first option is radio system, and the second option is celestial system, and the third one is AHRS, and the last option is mapping navigation system. So, which one of the following does not fall under the positioning system? Whether it is a radio system or celestial systems or AHRS system or mapping navigation system. So what is an answer? That is C. I have said that it is a resource systems. Okay, just like a VRS, that is village resource systems, like that it is also a AHRS system, is nothing but an resource systems. So it is it does not fall under the positioning system. So like that it is an correct answer. Okay, next question. How is the velocity of an aircraft measured by passive radio system? How is the velocity of an aircraft measured by passive radio systems? The first option is Doppler shift, and the second option is velocity data is transmitted by the aircraft and received by the station, and the third option is secondary surveillance method, and the last option is satellite mapping. So what is the option? So please note this question, please. How is the velocity of an aircraft measured by passive radio systems? How is the velocity of an aircraft measured by passive radio systems? Whether it is a Doppler shift or velocity data is transmitted by the aircraft and received by the station, or secondary surveillance method. The last option is satellite mapping. So what is an answer? That is A. That is Doppler shift is the velocity of an aircraft measured by a passive radio systems. So in this session I have covered so much of things. That is, whenever we are having the transponder, what is a transponder? That is transmitter and receiver combination in our satellite is going to be calling as transponder. So in this we are having so much of functions of the transponder. Okay, so I have covered with the types of transponders. Why? Because in our transponders we are having so much of functions. That is, it can receiving the uplink frequency and from the transmitting earth stations, and it is going to be amplifying the received signal, and it is going to be translated them into the downlink frequency, and it is amplified again, and the downlink frequency signals are going to be transmitted to the receiving earth stations. Okay, so in this not only with that, it is also having the filtering process which is used to channelization, and it is also going to be used to eliminate the interference. So in this session I have covered the types of transponders. So based on the configuration we are having the three types, that is single conversion transponder and double conversion transponder, and the third one is regenerative transponders. So when we are having these three types, what is the single conversion means? It is the name suggests that it is a single. That means it is having the single frequency translation process from the received signal to the transmitted signal takes place within our satellite. That means only single time it can be having the translation. Okay, that is the single conversion transponder. And the next one is double conversion transponder. So what is the use of this means? It is nothing but it is similar to the single conversion only, but there is a difference that it is having the double frequency conversion is going to be carried out in our satellites. Okay, two times it is going to be converted. It is going to be converted into two types of frequency translations. That means two times it is going to be translated in two ways. So that's why it is going to be calling as double conversion transponder. So what is the main advantage of double conversion means? It is having the greater flexibility, and it is also having filtering process, and maximum gain is going to be increased, and the quality of the frequency signals is also going to be increased, and the selectivity at lower IF level is going to be very easier when we are having the double conversion transponder. That means selectivity, when we select some particular signals at lower IF levels, it is very easier when we use the double conversion transponders. Okay, so that is the main advantages of double conversion transponder. And the last one is regenerative transponder. So when we are having the two transponders, that is single conversion transponder and double conversion transponder, we don't have any differentiation between the transmitter section and receiver section. Okay, so it will not differentiate that whether where the transmitter section ends or whether where the receiver section ends. So like this, it is going to be not done within this two types of transponders. But whenever we are using the regenerative transponders, it is having the differentiation between the transmitter section and receiver section also. Okay, so this is about our transponders. I have told about the all of the blocks which are involved in the each type of transponders. Okay, this is a single conversion and double conversion transponders and regenerative transponder. Okay, so I have told about the applications of transponders also. Why? Because whenever we are using the satellite communication, all of the applications which are comes under the satellite communication, which will comes under the transponder also. So the first option is communication. Whenever it is going to be used for communication, we are using the transponders, and is also used for navigation purpose, and is also used for map making. At the same time, it is used for scientific experimentation. It is used for monitoring of the earth's environment, and it is also used for the astronomical observations. So like this, these are all of the applications under the transponders. Okay, I have done with the number of quiz based on the satellites I have seen with this. So thank you so much.